Hello and welcome to today's physics class. We're diving into the concept of relationship between capital G and small g. So we said capital G is called universal gravitational constant, and we said last class that the value is given as 6.67 times 10 to the power minus 11. Next up, we have small g here. Small g, as we know from secondary school, is called acceleration to the gravity, and the value there is given as 9.81, right? That's the most widely used, 9.81. Some use 10 meter per second squared, it's still correct, but the major used value is 9.81. All right, that's your little definition or little enlightenment I can give about capital G and small g. For this class here, we're looking at relationship between this capital G and small g. You heard the concept here. Here is a concept. Let's assume that the earth, usually we know that the earth is spherical in nature. Here's the concept here. I'm not saying that the earth is circular in nature. Let's assume, please, look at my word, please. Let's assume the earth is circular in nature, and let's say I'm placing a mass at the center of the earth here, and the distance between the mass of the mass, right, of the object I place in the center to any circumference of this circle is known as RE. This R signifies radius of Earth, right? So I'm saying that if I place a mass at the center of the Earth and the distance from the mass to any part of the circumference of a circle is known as what? Radius of Earth. And the mass of the Earth is given as this part here. This becomes the mass of the earth here. So I'm saying that the force of attraction between these two masses here so the force of attraction between these masses M and ME, that is the force F of attraction between these masses M and ME. So normally our attach G, capital G, so M and what there? ME all over my distance here is RE. So RE all what there? All squared. I'm trying to relate this formula here with our normal concept of Newton's law of universal gravitation, that we said that F is equal to capital G M1 M2 over R squared. I'm trying to relate this with this one here. So here's the concept, please. Look up this. Here is a concept. At this junction here, call this man here, call it equation 1. I'm trying to get relationship between capital G and small g. At this junction here, call this man equation 1, please. If this man is equation 1, go back to your Newton's second law of motion that states that the rate of change of momentum is that proportional to the force. Is that proportional to the force that takes place in the direction of the force, right? Yes, that's like the concept there, right? So basically, I'm saying that from Newton's second law of motion, we know that F is equal to what there? Mass times what there? Gravity. Call this man, call it equation what there? Equation 2. At this junction here, I'll try to equate equation 1 and 2 together. That is, equate this F. F is equal to F. So F equal to this F. The first F is this, and the value here is I have capital G M ME all over RE squared is equal to this F is what? MG. And at this level in mathematics, if I have the same value on the numerator and the numerator or denominator of a equal values, hold on please, if I have equal to in between two expressions such that the numerator and the other numerator are equal, denominator and another one are what, are equal, here's the concept: if they are the same, they can cancel out. What do I mean? I can see mass here, I can see mass here, so I say that this mass now can cancel this mass here. So all I have left, I'll have that G ME over RE squared is equal to G. In essence, G, small g, is equal to G ME over RE squared. This formula is known as the relationship between capital G and small g. That is, this formula is known as the relationship between universal gravitational constant and acceleration due to gravity. So I have this formula as shown in front of you. So last class, I said that I want to prove to you, or I want to derive how or why capital G is equal to 6.67 times 10 to the power minus 11. Why is so? Why is the value so? Let's do the proof, please. To prove to you why G, capital G, is equal to 6.67 times 10 to the power minus 11 Newton meter squared per kilogram squared. Let's do the proving to this value, please. First task, to do the proving to this value, I have to make G subject here. I'll have to make G subject, please. So making the subject here, this over 1, GME times 1, I'll have GME. M is mass of Earth, is equal to G times this, that's G radius of Earth squared. I have this, please. First things first, let's make the subject. Divide by ME, divide by ME. So ME cancels out ME. I'm left with capital G. So I'm saying that capital G is equal to small g RE squared over ME. There are some constants you need to note, like you need to know them. That is, note that, hold on please. Note something please. Note this please. Note that, note this please. Note that small g is equal to 9.81. We all know this. Next up, note that the radius of Earth is equal to 6.38 times 10 to the power 6 meters. We know this one is what? Meter per second squared. This is in meters. Note that the mass of Earth, again, is a constant value which is equal to 5.96 there. Sorry. 98 times 10 to the power 24 kilogram. Of course, mass is a kilogram. So that's like the constant values you need to note. So in essence now, to get the value for G, what is this? So I'm saying that G now, capital G, is equal to small g, and that's 9.81. So 9.81 into RE squared, that's the root of X. This one, 6.38 times 10 to the power 6 all squared all over ME, that's mass of Earth, 5.98 times 10 to the power 24. All right. From here, if I'm to divide this, look on this, I'll get that capital G is equal to 6.67 times 10 to power minus 11. What there? Newton meter squared per kilogram squared. I've just literally showed you how to get the constant G, which is equal to 6.76 times 10 to the power minus 11. So thank you for joining my channel membership. So thank you for joining the WAEC/JAM membership. If you haven't done so, do well to go to my membership opportunities, or perhaps you see a join in the video, like in the screen on under down, you see under download, all those stuff there, you see a join button. Click on join. You see a access to jam/y class. You click on the jam class that I'm showing here. Click on the jam and purchase it to get access to over 200 plus video for chemistry, mathematics and physics. All right, so I haven't said so. So this is how to get relationship between capital G and small g, and also basically this is how to get the value for capital G, which is 6.67 times power minus 11, as you can see. All right, if you enjoy this class, do well to like the video, leave a comment, share to your friends and classmates so they can learn too. Also, do well to visit my website at www.ghanabakery.com/courses there. I have close to over different courses, different topics, science courses there. You can go to my website and check for the courses you are interested in buying or purchasing. You can buy the course there. I get a full lifetime access to those courses. Also, do well to join the channel membership. That's a very big privilege for me, right? Is simply a way whereby viewers help the creator that creates videos. So do well to join the membership, right? So to further improve our quality content creating. All right, so do well to subscribe. All right, see you next class, and welcome to Excellent Link Academy. In the next class, we'll be looking at several higher examples for the last 10 years under gravitational field. All right, see you in the next class.